Welcome back. So we've spent a good bit of time looking at forces between two charges. So now we want to think about what happens when we have additional charges. So there are many possibilities for how charges might be arranged, but the basic idea is that we can find the force caused by each individual charge, and then we add those forces together. This is what is called the superposition principle, and this is a fancy way of saying that the total electrostatic force on a charge is found by adding up all the forces exerted by the individual charges and then adding them together. Remember, forces are a vector, so that means that to add them together, we have to do vector addition. So we have an example here. We have a positive charge, charge 3, and to its left there are two other charges. Parallel to it there is a negative charge, charge 2, and at an angle there is a negative charge, charge 1. So to find the net charge, we find the forces exerted by each of these charges, and then we add the vectors together. So we'll start with the force on 3 by 2, force 3, 2, and so this force is pointing to the left because the positive charge is attracted to the negative charge, and this force is all along the x component. The y component is 0, and it is negative because the force is pointing to the left. Charge or force 3, 1, however, is at an angle. So it is a repulsion because both charges are positive, and we have an x and a y component. This is a 3, 4, 5 triangle, so the angle is 37 degrees. You might keep your eye open for 3, 4, 5 triangles, and remember the angles. They sometimes pop up on standardized tests, and they pop up all the time because they are convenient to work with. If you remember the vector components from way back in 201, we get the x component of the force by taking the force times the cosine of 37 degrees, and the y component is the force times the sine of 37 degrees. So the vector here is pointing up and to the right, and to find the total force on charge 3, we would add up the x components to find the total x component, and we would add the y component, which only comes from force 3, 1. If we add these all together, the force is pointing up and to the left, and well, slightly to the left. And as you can imagine, we can do a ton of problems like this. We're not going to do too many since you've already done vector addition and we've got a lot of other things to work on, but we will put one or two of these kinds of questions on your homework, and it is nice because it combines a few concepts to make sure that you get all this stuff. I think I'll save working through one of these questions for the Zoom classes. However, we will ask you a number of more intuitive questions to make sure that you sort of understand this concept of superposition. Okay, so here we have a +2 point charge that is placed at point A, and we want to know what direction the force will face, or the force vector will face. So here we have two positive charges, also plus 2c. So we want to know which direction the force will face. So to do this, what we want to do is we want to draw our free body diagram in order to see in which direction each of the forces are pointing. We look at the top charge, and we see that that is a +2 charge, and so since they're both positive charges, they will repel each other, so the force is going to point down and to the right. When we look at the bottom charge, the force will point up and to the left. Again, this is a repulsion, and so what happens here is when you look at these two forces, if we add them together, you should see that the y components are going to cancel out, and the x component is going to point directly to the right. So that means the force will point to the right. Notice if we change the question and we made our charges -2c instead of +2c, then the force will point to the left. Also, we can change the charges on the fixed charges. If we change one to -2c and leave the other at +2c, well, what then happens? Well, if we're looking at a positive charge, the positive charge will have a force component pointing towards the negative charge and away from the positive charge. So then the force will point up or down depending on the arrangement of the positive and negative charges. Anyhow, you guys will get to practice this one a few times. I think we have one on the classwork here, and we also have a question like this on the homework. Good luck.